Ich? Oder wer? Okay. Okay. Welcome back. So the next speaker will be Noy Pearl, and we'll talk about Cypher Injection, the new SQL injection we aren't aware of. I have to be honest, I haven't even been aware of Cypher Query language, but yeah. Let's go.
Thank you so much. Okay, so hi everyone, my name is Noy, and I'm super excited to be right here. First of all, I really want to thank everyone for sitting right here after lunch. My whole mission today is to keep you awake after this. And I'm going to do so by talking about Cypher. So indeed, Cypher is not SQL, and this is not a talk about SQL injection. There are only 2 slides about SQL injection in all this talk. So let's start. So I'm working as a security researcher, and I was one of the group members to create the Capture the Flag challenges back in OWASP AppSec 2020. I really like to learn about new stuff and also to dance, especially after I find a vulnerability. And I have the best dog ever, but it's more accurate to say that he actually owns me. Okay, so I wanted to actually have 5 takeaways out of this talk today. First of all, I want every one of you to really know what is Cypher and how to use Cypher, and what exactly is graph database. And I really want you to know how to inject into the Cypher query. And I want you to be able to take your attack further and escalate your attack to cause as much damage as you can actually have. And eventually, I want you to know how to be protected from these kind of injections. And to talk about, of course, what we can actually do with this, I built a playground for you. But I'm spoiling a little bit, so let's start. Cypher. So forget for 40 minutes about everything you know about the word Cypher. We're not talking about Caesar Cypher or Cypher of any crypto. We're talking about a different kind of Cypher. And we're going to talk about Open Cypher, which is just a query language. So you write queries in Cypher language. And those queries perform actions on something that's called a graph database. So pretty simple, nothing too fancy right here. But let's first of all understand what exactly is a graph database. So we have our own familiar relational database, like some SQL database with tables and rows. And we have on the right a new database, a graph database. So we have some weird circles and arrows. And we can read as SpongeBob lives at Pineapple House. And there are a lot of new databases actually right now that use graph database. So we have Neo4j. They are the ones to open source Open Cypher language. There is Redis Graph, which is just an extension of Redis that enables you to write in Cypher on Redis database. And there is Amazon Neptune that enables you to also write Cypher. But these are only a few examples. There are such more examples today. And let's understand what exactly is Cypher, because we talked about graph databases and about the fact that we use Cypher to perform actions on graph databases. But let's just take a word of SpongeBob that I used, and I represented it using a graph database. So I created here some characters and places, and I created also relationship. Those are the arrows that connect between those circles. And this is just how a graph database looks like. So pretty different than what we already used to. And if we take specific part of it, so we can read it as SpongeBob is a friend of Sandy who lives at Sandy Street. And it's just a single part from the database. So no tables, no rows or columns, only these kind of things. And let's understand what are those things. So we have our terms. There is the circle, you can call it node. And there are relationships, those are the arrows that we talked about. And if you want to dig deeper into Cypher, then dismiss, match, and return for a second. You have variables that you can actually define, such as here I define a variable called C. And you have labels, such as character and place. And you have also properties. Now you can assign properties to different nodes. And here I assign a property called name to the SpongeBob character node. And this is just the basic terms of Cypher. So we talked about the terms, but let's understand what are exactly the syntax of Cypher. So for example, in order to get all the characters, we use match and return. Match, and we define a variable called C to represent all the characters, and then we return the C. Now we have to use return after match, so we will tell Cypher exactly what to return back. And this is a simple example, but if you want to be more specific, we can just return characters by specific name. So we'll again get all the characters, and then we put a where clause, where see that name equals to SpongeBob. So in that way, we get back all the characters with the name of SpongeBob. I hope that makes sense. Nothing too fancy right here, but this is not the usual form that we're used to. This is not like select from, but match return. Okay, so I talked a little bit about Cypher Query, but let's dig into the more interesting stuff that you all came here for. So let's try to inject into stuff. Now I'm gonna start with SQL Injection. Again, only 2 slides about it. Don't kill me for this. But let's understand how it works in a nutshell. So imagine that there is a table called characters, and you get the name value, like this SpongeBob green text, from some user. So this would be your user input. You return back to the user only SpongeBob according to the name. Nothing fancy right here. But in a case that the user is actually an attacker, they will insert this red background text. Instead of SpongeBob, we'll insert SpongeBob with double quotes to terminate the string. And then we'll insert a term that will return true always, such as or 1 equals 1, and 2 dashes to comment out the rest of the query. Now what will actually happen right here is that for each one of the rows in the tables, it will be checked whether the name is SpongeBob or whether 1 equals 1. And since 1 equals 1 we return true always, then the attacker will get back not only SpongeBob, but other nodes as well, other characters. So this is how SQL injection works in a nutshell. Now let's use this knowledge in order to inject into the actual Cypher. So let's get back to Cypher, now with this knowledge. And this is just a similar example to what we saw right now. We get some user input, and we return the specific character according to the name in Cypher. So in the case that the user enters SpongeBob, we return the node with the name of SpongeBob. Nothing fancy here. But let's try to inject into Cypher. So instead of returning just SpongeBob, the actual attacker will insert all this red background text. They will insert SpongeBob with single quote to terminate the string. And then we'll insert or 1 equals 1 and return C with 2 slashes to comment out the rest of the query. And what will happen will be this. Now the attacker will be able to get other nodes as well, not only the node with the name SpongeBob. And this is like the trivial attack. And this is how it's gonna happen. Now you can just stop me right now and tell me, hey, we're an attacker from outside. We have no idea how the database actually looks like and how the query actually looks like. So how will we know to inject return C? Because we don't know that there is a variable called C in this query, because we didn't develop this specific application. We are an attacker. And I will tell you that you're probably right. This is an issue that we are going to overcome in a few slides. And just, I'm gonna solve this issue in a few slides, but let's keep with the examples for now. So the next example will be to delete. We don't want only to get data, we want to actually tamper with other data. So we will inject here delete C, so that we will be able to delete the node of SpongeBob. But we don't want to delete our own poor node, we want to delete other nodes as well. So what we will insert will be, in the same example here, this one. Now notice that we inject all this red background text, and we will inject 2 clauses. The first one will be match to get all the characters. We will define a variable called all, and then we will delete this all. So we will delete all the characters. So again, we're getting all the characters and then deleting all of them. And we can do this on character and on place label, and basically any label that we want that exists in the database. But we don't see the query. I'm returning to the question that I gracefully avoided. We don't know to inject return C, and we don't know that there is a label called character in the database, because again, we're an attacker from outside, so how will we know to inject those kind of things? And this is an issue, and we're going to solve it. Now, in a real-world application, we do usually have blind injection when you don't see the response. So what we're going to do right now will be to exfiltrate data by leveraging a very legitimate functionality in Neo4j that is called load CSV. Now let's see how we can actually do it and bypass this specific restriction. So we can insert load CSV. Now let's talk a little bit about load CSV. This is a legitimate function in Neo4j database that enables you to import data from other CSV files. Imagine that you want to use like 10,000 rows. You can just import some CSV of 10,000 rows and use the data. Pretty legitimate. And you just use it in your own Cypher query. So you can insert load CSV from, define some URL to some CSV file, and by that you will be able later on to use this CSV data. But we are going to use this kind of legitimate function maliciously in order to leak data from the database, from this Cypher query, outside back to us as the attacker. So we have a trivial example here of blind injection where we cannot actually see the result of the query. We have no idea how the database actually looks like, and we still want to be able to inject into this database to leak a lot of data and eventually even escalate our attack further and reach other machines as well. So let's use this load CSV functionality. Now this will be our injections. This will be one injection. Those 4 lines will be actually the injection. And let's see what we can actually do right here. We use call db.labels to get all the labels in the database, and then we use load CSV from in the injection. So we will get those labels and append them at the end of the URL to our own server. And then the last line doesn't really interest us. We comment out like the rest of the query, and the injection will work. But what we actually do right here is, first of all, we're getting all the labels, and then we appending them to a request that will be sent to our server. So this is pretty mind-blowing, because imagine that you have a server, and you just inject like Cypher injection, and you're able like that to leak the labels in the database. So notice that the actual leaked label, the character, is coming at the end of the URL to our own server, just like that. And just like that, we were able to actually perform an injection where there is a blind injection and be able to get different parts from the database. So first of all, we leaked all the labels in the database. For each one of the labels, we get a separate request. And notice the second line, the user agent, is actually no load CSV Java. It means that the HTTP request was sent directly from this load CSV function in the injection itself. So we leaked labels, but let's try to leak more stuff. So now that we know that there is a label called character as the attacker, we will try to load the keys, the actual properties. So again, match with the character and then load CSV from. And this time we'll use epoch test join with keys C. Now notice the third line. Keys C just returns us all the properties of this character. So what we'll get back would be now the name of the character, because this is actually a property. And for each one of the properties, we'll get separate requests. But basically, here we managed to leak now the properties to our own database, to our own server. OK, so we leaked labels and properties. Now let's try to leak the actual interesting stuff, the names, the SpongeBob and Patrick things. So we get all the characters and then use load CSV from. And this time we'll append at the end of the URL c.name, because we know that there are characters right here and there is a property called name. So we'll get back Patrick and Mr. Crab with the typo I made. But anyway, we'll get those kind of characters back to us. And again, those screenshots are coming from my server as the attacker. So in that way, I'm able to leak different parts of the database back to me. OK, so we're able to get a lot of data from the database and to tamper with data. Now that we know how the database looks like, we can actually inject, delete, and update and change things. But we want to do more crazy stuff today. We want to be able to cause like more damage than what we already done. So let's see what else we can do. Now we're going to escalate our attack. So this is the more fun part. First of all, we're going to cause denial of service of the database and prevent from other users to use the application and the database itself. Then we're going to perform SSRF and RFI. And I'm going to explain exactly what are those when we reach there. But basically, we're going to escalate to other machines as well. So we're going to read sensitive files, access protected endpoints, leak keys, and perform lateral movement eventually. And I'm going to show exactly how we can do this in the cloud. And eventually, we're going to talk about alternatives to load CSV and other databases as well, not only Neo4j. OK, so first of all, we want to be able to cause denial of service. So what we can actually do in the injection, First of all, we will call dbms.listConnections. We put this in the first injection in a similar way that we injected previously, and we leak now the connection IDs back to us. And after we got from the load CSV the connection IDs, we can actually send another injection to kill the connections. So either kill one connection or kill a list of connections. And we can do so in an automated script so that every time that a new connection just goes up, we can kill it. And by that, if we do it fast enough with a lot of machines, for example, we can actually cause a lot of latency in the database, in the queries that are executed. And if the application is really dependent on Neo4j database, then we can hopefully also cause a denial of service in the application itself. This really depends on the roles and permissions that you actually have. If you have the default admin role, it will be successful, but I'm going to talk a lot more about roles and permissions a little bit later. So who doesn't like to drop databases? We can actually leak all the names of the databases back to us in the same trick that I showed previously of leaking the labels. And then in the second injection will be to drop the database. So again, we'll send two injections. The first one to leak stuff to us, such as leaking the databases, and the second one to actually drop what we want. So this time we will drop the database that's called SpongeBob in the same injection. But again, we want to do more damage. We're like Patrick today. So let's see what else we can actually do. Now we're going to do something interesting. We're going to cause something that's called SSRF, which is a web-based vulnerability, where an attacker is actually constructing a malicious HTTP request. It reaches through the firewall to the server, and then because of how the request is maliciously constructed, the server either sends a request to himself or to another internal server, gets back the sensitive resource, and returns it back to the attacker. So it actually looks as if the attacker actually sitting after the firewall and not before it, and is able to manipulate the server to send a lot of internal protected HTTP requests. And this is pretty strong. Like that, you can leak a lot of sensitive keys and access hidden endpoints because it looks just as you are sitting in the server, or it looks just as you are the server that is sending the request, and not the attacker that is after the firewall. So we're going to use SSRF right here in the same trick of flow TSV and have a lot of fun. So let's try to do so. What we can actually do right now will be the same trick of flow TSV from. Again, we will inject this in Cypher, but this time we won't define our own web server URL. We'll define the URL to some internal resource. Now, in order to discover the resource, we can just perform enumeration. We can see what is the actual infrastructure of the server. For example, try to get common file names, for example, if it's in Python, then Django. There are a lot of ways to do so. But let's just imagine that we know that there is some secret here and some internal host. So we will send in the load CSV from right now this URL to internal secret. And in that way, we will actually make the vulnerable Neo4j server send a request to one of the internal servers and return back to us any protective resource. So we'll be able to actually perform HTTP requests to internal web services and get, for example, SSH keys, depending on the user that is trying to perform it. But eventually, what we want to do, like if we're talking about cloud environments and something more focused, we can actually query something that's called metadata service, which is a service in AWS that sits in a static IP, unless you change it. And you can actually get a lot of metadata information about users, credentials, roles, and even credentials. So what you can actually do is get credentials from the service to some AWS accounts, and then, for example, query the secret manager of AWS, or try to escalate to other machines with those credentials and perform lateral movement. So one fix right here will be to upgrade to version 2 of metadata service, because in version 2, you actually establish a session in front of this service, and you have to include this token that you get in the header of the HTTP request. Now, since I didn't find a way to include custom header in the HTTP request that comes from this load CSV, it will be pretty weird to do so. I think that if you have actually version 2, it won't be possible, because you really have to define a custom header. So we talked about the abstract of SSRF through LoadTSV, but let's see how you can actually do so doing an injection. So I defined some very sensitive endpoint that should never, ever be exposed to outside world. And this is the injection that you can actually perform when you're an attacker. Now, you will inject those 4 lines, and let's see what happens right here. So first of all, you can actually use twice LoadTSV from. The first LoadTSV from will be to get the secret and see the keys.txt at the end. And in the second line, you save this secret actually as a variable that you define that is called secret. And in the third line, then you cause another HTTP request now to your server, and you add a secret at the end of the URL. So you will leak the secret back to you after you got it internally. So again, what actually happens right here is that Neo4j database will run the Cypher with the injection of you. We try to run this load.csv from. We'll try to get a load.csv file from this internal API keys.txt. It doesn't really matter that this is text file, not CSV. Then we'll save it as secret, and then we'll send another HTTP request using load.csv from to your server with the leaked key at the end. And notice the secret in the index of 0 because it just like as we got some CSV file, but not really. So it treats it like that, like a list. And the 2 slashes at the end of the 4th line just to comment out the rest of the query. So this is just how the injection will work. And if you try to see your requests that are coming to your web server as the attacker, you will see this request, and you will see this actually secret that was leaked. Now, besides of leaking just nonsense information from your routes, you can actually leak source code files and other hidden files. I tried to leak the source code of another application that ran in another web server, and I got it, I did it. And like for every line, you get some separate requests, but you can just build it in Cypher as you wish to be more beautiful. But basically, you can just right now perform SSRF by using the very simple Cypher injection. Okay, so we understood that there is some potential right here in the ability to have Cypher injection and to also escalate to other machines and make your attack much bigger. So we talked with Neo4j company, and we showed them this, and they were very awesome about it. They actually added a page in the blog that really talked about this specifically, and also added a new configuration to treat this kind of possibility. And I'm going to show it in a few slides. But my thought was that, OK, there is this load.csv, but what will happen if load.csv will be blocked from some reason? I wanted to try to find another way to actually leak stuff, and not only by load.csv. And then I searched, and I found something that's called Epoch plugin, which is a very common plugin to use if you're using a lot of stuff in Cypher. It is top 1 or top 2 of Neo4j. And it's just an extension that enables you to do a little bit more than what you already can in Cypher, and adds a lot of functionality, such as load and import and export procedures. And my thought was to do exactly the same thing, but now in Epoch, if load.csv will be blocked at some point. So I used the same injection, the match character, but now called something that's called Epoch load JSON, which is a procedure to try to load external JSON file. So what it does is actually cause an HTTP request to be sent to any URL you want. In this case, you will try to send an HTTP request to the attacker URL with the same leaked c.name at the end. So again, right here, you try to do the same injection. Right now, not in load.csv, but with Epoch library. And again, you will get a request back to you as the attacker with the leaked information, with the leaked character. OK, so we talked a lot about graphs, about Neo4j, about protections, about how we can actually bypass some things and perform SSRF in our service and steal a lot of stuff by using specifically very simple injection in Cypher. But let's really try to understand how to get protected from those kind of things, or at least reduce the attack surface in case you have some injection in one of your applications. So first of all, in order to prevent Cypher injection, you can actually use something that's called parameterized queries. Now you have this also in SQL injection prevention. This is the good way to do so. So imagine that you write code that gets some value from the user. You will specify a parameter, and you can see the name, this is just a placeholder parameter, and the second argument of the function will be the parameter that you get from the user. So we get the name from the user. We don't trust the name parameter. That's why we use these parameterized queries. And what actually happens is that if the attacker tries to perform some escaping to inject some double quote or escape from this string or this query, those will be escaped and will be treated as the double quote string and not as the string that terminates the query. So this is the good way and how you can actually avoid from injection in Cypher. And this is the you should never do so example. You should never insert, like, append your inputs that you get from the user just as is without any sanitization or validation. So please use the first one and avoid at all costs from using the second one if you don't have any validation. But we're pretty realistic today, and we know that there can come a new developer that tomorrow will write some vulnerable code that is vulnerable to Cypher injection and want to reduce the attack surface. So we have something in Neo4j that's called role-based access control, which is actually means that you have a lot of roles and users and privileges that you can actually define. And for example, you have granular roles such as public, reader, editor, and admin, and much more. You should just use the user with the least permissions, but that can actually perform 100 of what you actually want. And each role right here is built on top of the second role with a few more privileges. So for example, if you have a very sensitive database that you want only to read data from, and you have another not so sensitive database, you can define two users with two roles. The first one will have the reader, one for the sensitive database. And if you will have an injection in the not sensitive database, then you can also perform actions on the not so sensitive one. And if you have an injection on the sensitive database, you can only read data, but not to change it because of this user that you defined previously. What else you can do? You can actually revoke some privileges from some roles. So you can use the common reader role and change it and tamper whatever you like. And another suggestion that we got, specifically this one, was a nice suggestion we got from Neo4j. You can just remove epoch if you don't use it, or there is in version 4.3 a way to define a allow list in epoch. It means that you can actually define in the configuration of Neo4j which procedures you actually want to allow and only them. So for example, if you want to allow only import procedure or export, you can actually define it, and if an attacker will try to perform other procedures, they will be blocked and the injection will be blocked. So it's nice, but we got something stronger. We got something from Neo4j recently, according to communication we had with them, and there is this new configuration that he added in 4.4.4, and it was renamed in the newer version of 5 and above. And what you can actually do right here is define a block list that blocks any communication from Cypher outside. So it doesn't really matter if you have an injection in load CSV that the attacker uses or epoch procedures. You can just, or just tomorrow there will be a new library. It just prevents the communication to outside, and by that prevents any leakage from the attacker to outside. So you can actually define a range of IPs, and if the IP is in the same block list and the attacker tries to inject with an IP that is in this specific block list, the injection will be blocked. So it supports IPv4 and IPv6. And this is an example of message that you will actually get if an attacker tries to leak data with load CSV, but you defined correctly the block list. So this was my attempt when I tried to leak data with load CSV after I configured my Neo4j database with this new configuration. So it was blocked by the configuration property that I told you previously. And when I tried to do so again, but now with this epoch load JSON, then I got also blocked. So it seems working. And it's pretty nice because if tomorrow there will be a new library that enables you to send requests externally back to you as the attacker, it will be also blocked if the developers configured properly this kind of configuration. And in the bottom, there is also the documentation that they added following our work with them, so we can actually see those. So I talked a lot about Neo4j and graph databases and denial of service and all of this fun and cool stuff. And I want to talk a little bit about Redis graph that's becoming more and more common nowadays. So I really try to understand what we have in this, because Redis graph is just an extension to Redis. It enables you to write Cypher queries that perform actions on Redis database. And I saw that you can actually have parameterized queries in Redis graph. And some procedures are supported. You can actually use in the injection db.labels. And you can use substring and case when in such a way that you can actually try, for example, to brute force the characters and get back an error every time that you successfully do it. So for example, you can try to get the first label and to see if the first character of the first label is A, and then inject case when and try to do something that causes an error. So for example, try to see if the first character of the first label is A, and if so, try to convert this to integer and with the 1 divided by 0, which will cause you an error. So if you get back an error from the web server, you know that you hit this case when, and you know that the injection was successful, and you will know what the first character of this first label was. So this is kind of how you do it, and this is just an example of to integer and how it works. But basically, you can just try to use anything in the documentation of Redis graph that causes an error with this case with case when, and try to see if you get an error according to what you actually hit. And I try to understand if there are roles and permissions, and I actually got to this issue. It was still open when I got to this, and I didn't find any roles and permissions, something similar to Neo4j, but for Redis graph, unfortunately. Okay, so we talked a lot about graphs and injections and what can an attacker actually do with this, but I really want you to exit from my talk with something that you can actually do and perform. So first of all, I want to advise you to really go into the vulnerable playground that I created. There's going to be a barcode at the end of the talk. Basically, I really invest a lot of time for you to understand how it works. It is all Docker composerized, and it supports Redis graph and also Neo4j databases. And after you understand how those injections work, you can actually maybe fix those injections in your applications if you're some developer or security engineers. You can also bug bounty. I didn't find, when I started my research 2 years ago, any bug bounty write-up about Cypher injection. And I think that there can be a lot right now. And if you Google for Cypher injection, you won't find that many results. When I started my research, I Googled for Cypher injection and could find barely 2 articles about it. So because this is a topic that not a lot of people talk and know today, these Cypher injections, you have high potential to really find an injection in one of your bug bounty applications. And eventually, you can just perform the mitigations that we talked about here and reduce your attack surface in case you will have in the future an injection in Cypher, or just profit. Now, those are just screenshots from the vulnerable application that I created. It all has some SpongeBob things. So just application. There are a lot of routes that you can actually try to inject to. Some Swagger, and yeah, a lot of rabbit Easter eggs. But basically, that's it. So I want to give, at the end, credit to the person that wrote the beginning of the write-up about Cypher injections that I found 2 years ago, and also the basic vulnerable playground that I based my playground on. So thank you for that. And that would be it. So thank you, everyone. I really advise you to try to scan this QR code and understand, if not how to eject, but what is exactly graph database and how to use it. And so feel free to ping me, to ask me for any question out in the hall. But most of all, thank you, everyone. If you have any questions, then go ahead.
Thank you for the very nice presentation. For the SSRF, do you know of any opportunities to use other HTTP methods or at HTTP headers? Yeah.
Okay, so awesome questions. I also try to understand if there is something else that causes you to send an HTTP request. At the time of researching, I only could find load CSV, which is the built-in thing, and Epoch and maybe other third-party libraries. But maybe now there will be another option to actually use another new function nowadays. Maybe in the 5 version, the new version, you will find some load something else that enables you. Load JSON maybe. I think if you dig into the documentation, you can actually find the answer pretty easily.
So right now it's only GET request.
So right now, this is only sends a GET request, yes. I didn't find a way to perform POST. If I will, or somebody from you will find it to be amazing. And yeah, you're right, much more capabilities when you have an SRF. And I also didn't find a way yet to include the custom header. Also, this would be pretty awesome to do. Thank you.
Okay, any other questions?
Yeah, thanks for the talk. Really interesting. I just wanted to know, did you already research any other databases, graph databases, except for the 2 you mentioned?
So actually, I also started a recent research on Amazon Neptune. Nothing interesting so far, but there are so many databases nowadays that I hear about that are starting, like, this is a new graph database that I hear about, and I guess there will be much more in the future. Yeah.
Thanks.
Thank you.
Okay, if there are no other questions, then thank you for the talk.
Thank you, everyone.
Yeah.